So 10.2 is going to take what we did with circumference and start applying it to arcs and angles. So arcs are on the outside of the circle, and we name arcs by their endpoints. And a minor arc is an arc that's small, it's less than 180 degrees. We name arcs by their endpoints, so that's arc AB. And for lines, we put a straight line above. Arcs, we're going to put a curve above. Major arcs are something that are over 180 degrees, so I want to go from A all the way around to B. But to denote that, I can't just call it AB. I need to come up with a third point here. Oh, that's already on there. B's already there. Let's change that to D. And when I do this now, I want to go from A through D all the way to B and put a curve over that. Each arc has an angle that it corresponds with. That angle is when I connect those to the center. For this minor arc, we're talking angle ACB. And in 2 slides, we're going to see a special property between angle ACB and minor arc AB. So, an arc with endpoints on the diameter of the circle, like the example ADB and arc AHB, those 2 arcs are half the circle, so they're called a semicircle. You guys have heard that word before. Semicircle or a semi-major arc are a couple other ways you could hear it. So the measure of a minor arc is equal to the measure of its angle. That corresponding angle. If the angle in here is 45 degrees, the arc out here is 45 degrees. And the arc measure for a full circle, if I were to start here and go all the way around, because it matches with the angle going all the way around, an arc can be up to 360 degrees. So take a minute to draw this picture. We're going to find ST, that arc right there, and we're going to find arc QU. So in order to do that, I need to find the angle that corresponds with it. Since here's 45 and here's 60, I need to figure out what is this third missing angle here. And I know that half a circle is 180, so if I take 180 and I subtract 60, and then I subtract from that 45, I get that that angle right here that I labeled X is 75 degrees. Now if that's 75, my arc is 75 degrees also. For QU, it's a little different because I need to find this angle over here. Let me switch to green. I need to find that angle. So what I'm going to do is, since this is 45, I know that's 45 because I see this right angle, and 45 plus 45 is 90. Since I know that that's 45, the remainder of that half of the circle from R all the way around to U is 45, 180 minus 45, or 135. Since that's 135 right there, I can say that that angle is equal to the measure of that arc. Now let's throw in some algebra because this wouldn't be fun without it. I need to find X before I can find arc EDC. Now I know it's a minor arc, and I used 3 letters to describe it, but that just shows that I'm finding this entire arc. It's okay to label a minor arc with 3 letters. Just remember, you start from E, go through D to C, which is why it's this green one that I traced and not the other half of the circle, the other portion. So I know that these 3 that I put a little dot in, all 3 of those form a straight line. And a straight line is 180 degrees. So all 3 of those add up to 180. So combined like terms, I get 19x plus 9 equals 180. I'm going to get 19x equals 171. And when you divide by 19, you get x is 9. Now that x is 9, I need to find these 2 angles. If I can find those 2 angles, when I plug in x, that's going to be the measure of the arc. So we're going to plug in 9. 5 times 9 is 45, plus 3 gives me that this angle is 48. When I plug in 9 over here, I get 72 plus 1, or 73. And 48 plus 73 is 121. So the measure of arc EDC is 121 degrees. Oops, too far. So, arc measure versus arc length. The arc measure was what we were just finding. It's how far do you have to rotate around a certain point, and that's why it's corresponding with the angle on the inside. Because arc BD is the same measure as arc AC. You rotate about 90 degrees for both of them. Arc length is different. If you were to physically walk from B to D, it would take a lot longer than walking from A to C. That's arc length. Arc measures if you were standing in the middle and you rotated looking from one point to the other. So, radius of the circle is 12 centimeters. The circumference of this circle is 2 pi r, or 2 pi times 12. So circumference of this circle is 24 pi. So what's the length of the red arc? I know that 120 is 1/3 of 360, because 120 over 360 is 1/3. So since that's 1/3, maybe the red arc is 1/3 of 24 pi. 1/3 of 24 pi gets me 8 pi. And that's actually what it ends up being. This arc here ends up being 8 pi. This one ends up being 16 pi, because this angle is half of this angle. And this angle 120 is 1/3 of the entire way around. So we have an important proportion. Degrees over 360 equals arc length over 2 pi r. The amount of degrees the arc measure over 360, which is all the way around the circle, is the arc length, the portion over all the way around the circle, the circumference. Degrees over 360, arc length over circumference. Make sure you write that down. We're going to be using that throughout the entire chapter. So let's find the length of AB. Degrees over 360 equals arc length over 2 pi r. So 90 over 360 equals x over 16 pi. Now I could cross multiply here, but 90 over 360 is going to simplify to 1 over 4, which makes it a lot easier for me to do this math in my head. 16 pi. When I cross multiply, 16 pi equals 4x, so x equals 4 pi. So this arc has a length of 4 pi. Notice how there's no m in front of the AB. That tells me I want arc length, not the measure. Otherwise, the measure would just be 90 degrees. Circle's got a radius of 12. Arc that measures 2 pi inches. Find the measure of the angle. So we want angle over 360 equals arc length over 2 pi r. Now, angle I'm just going to replace with x. X over 360 equals 2 pi over 24 pi. I see a pi in both. Let's cancel it. X over 360 equals 2 over 24. You can simplify this as if you want. Either way, we get 720 equals 24x. So you got to take 720 and divide that by 24. And you get that x is 30 degrees. Okay, so we found one where we had to find arc length. We found one where we had to find the angle. There are some where you have to find the radius as well. So let's find the arc again. We want to find this arc length, so we got to use that same proportion. Degrees over 360 equals arc length over 2 pi r. We're going to cross multiply. 2 times 3 is 6 pi, so 6 pi times 60 is 360 pi equals 360 times x There's a 360 on both sides, so when you divide, you get x is pi. So these last three examples that we did came down all to that formula. Do we know degrees over 360 equals arc length over 2 pi r? If we have that memorized, these problems won't be too bad.